This protocol can help maintain the cargo stability, which can be both small molecules and proteins, through the use of the polybubble, which can in turn reduce the cargo interactions with the solvent. This novel technique can be used to improve vaccine coverage in the developing countries, as vaccine functionalities can often be compromised due to inefficient transportation and storage facilities.
To fabricate the polybubbles, first use a 1 milliliter transfer pipette to add 800 microliters of 10% CMC into a 0.92 milliliter glass vial. To synthesize PCLTA, mix 1,000 grams per milliliter of 14 kilodalton PCl and 200 microliters of DCM. To synthesize PLGADA, mix 1,000 grams per milliliter of 5 kilodalton PLGADA into 200 microliters of chloroform. Mix photoinitiator with the polymer mixture of interest at a 0.005 to 1 ratio and load 200 microliters of the resulting solution into a 1 milliliter glass syringe mounted on a syringe pump connected to a dispensing stainless steel tube with an inner diameter of 0.016 inch. Using a micromotor to control the forward and backward motion of the polymer tube, inject the polymer into the 10% CMC in the glass vial to form the polybubbles and cure the polybubbles under ultraviolet light at a 254 nanometer wavelength for 60 seconds at 2 watts per square centimeter. Then flash freeze the polybubbles in liquid nitrogen for 30 seconds and lyophilize the carriers overnight at 0.01 millibar vacuum and minus 85 degrees Celsius. For centering